Pre-Calc BC. Today we are going to continue working with logs, and today the focus is solving with logs. All right, so let's go ahead and get started here. When solving logs, there are just so many different ways to do this, and I feel like people prefer based on like what their teacher did last year. So we're going to do some of these a couple different ways, but I don't want you to think those are the only ways to do them. So please reach out if you are trying these in a different way and you just want to make sure that's acceptable. So when solving logs, one way to do this is to write it in exponential form to see the answer, and you can also solve natural or common logs using the calculator. If rounding is needed, round to the nearest thousandth, okay, but also usually leaving these in exact form is completely acceptable as well. All right, so for example, number 1, we are in log form, and again, what the directions said, I really prefer to move these to exponential form to help solve. So I'm just going to go ahead, I'll do my little loop here, and I have 5 to the third equals x, which is just 125. Okay, some people may choose to do something called exponentiating, which is not something I usually use, but it's completely fine. Basically, you take the base and you make these guys the exponent. The 5 to the log base 5 cancels, and we end up getting x equals 5 to the third, which again is just the same thing as we had before. All right, so then I'm going to do that same method for this one right here. I'm just going to change it to exponential form, x to the third equals 1/8. All right, and then one thing you can do here is you can just cube root each side. And the cube root of 1/8 would be 1/2. This one you would not want to exponentiate because notice your base here is an x, and so that would not be, well, I guess you could, right? Because you could say x to the third, and you would get 1/8 equals x to the third. So yeah, it doesn't really matter. I just normally wouldn't see someone do it that way because that base is a variable. All right, moving right along. So in number 3, we have natural log of e to the negative 2x equals 8. And so what we need to know is that natural log of e does cancel. All right, and there is a reason for that. This is actually getting more into the properties of logs, which will come up after our next quiz here. But let me just give you a little synopsis right now. Log base a of a, where a is just some value, is always going to be equal to 1 because when we move this to exponential form, a to the first power is a. So essentially, log base a of a is always going to cancel and just give you 1. Natural log of e is saying log base e of e. And so that is a 1. And again, something that we will learn when we deal with properties of exponents is that we're just going to be left with this negative 2x here. Okay, and so x is negative 4. All right, and that is that. Next, again, I just prefer to move to exponential form. So I'm going to say 5 to the x equals 625, or you could certainly exponentiate this if you'd like. And then we can rewrite 625 as the same base. It's 5 to the 4th actually, and you can use your calculator to figure that out. And then x would just be 4. So most of these are pretty quick. We'll get to some harder ones later. Okay, same sort of thing here. I'm going to go and put this into exponential form. 6 to the 5x plus 3 is equal to 36. And 36 can be written as 6 squared. What some people prefer to do is take this 36 and write it as a 6 squared right now, because then your log base 6 of 6 will cancel and you'll automatically have that 2 equals 5 plus 3, which we'll end up doing here anyways. So even when you do these different ways, they all end up kind of being the same thing in the end. So we should get a -1/5. This is the type of property I was talking about before, log base 7 of 7. This is saying 7 to some power is 7. Well, that's always going to be a 1. All right, so that's when we were in log form. Now we have some problems where we are in exponential form. So basically, if you have an exponential power or an exponential form, you can either convert it to log form, or we can use logs to solve. If you have a base of e, then I would strongly recommend natural logging each side, because then you'll have that cancellation occur. So we'll get -2x equals natural log of 1/3. And I would not evaluate this. I would probably just leave it like this, and then you'll divide by -2. And you can either leave your answer like this, or if you feel like typing it in and rounding to the nearest thousandth, you can. I'm just going to leave it like this. All right, so then let's try this again. We have an e, so I'll natural log both sides. Natural log and e cancel. I get 3x plus 2 equals natural log of 24. And again, this isn't going to look really pretty, but you're just going to solve it like normal. So we'll get natural log of 24 minus 2, and then divide by 3. So natural log of 24 minus 2 all over 3 would be your beautiful answer there. All right, so now let's look at some of these types of problems in context. So spreading of rumors. Ooh. A model for the number n of people in a community college who have heard a certain rumor is this, where P is the total population of the community and D is the number of days that have elapsed since the rumor began. In a community of 1,000 students, how many days will elapse before 450 students have heard the rumor? So you're given some information here. Let's go ahead and plug it in. Again, it says that N is people in a college community who have heard a certain rumor, and P is the total population. So the number of students who have heard the rumor, we're told, is 450. So that's N. Total population, P, is 1,000. And we here are solving for, oops, that's not right, D, which is the number of days that have elapsed. All right, so how would we solve this? Well, first things first, we should divide by this 1,000. I would not distribute it. It's just going to give you more work to do. So if you go ahead and divide by the 1,000 on each side, you should get a 0.45. All right, and now we're just trying to isolate our variable. So let's subtract our 1 on each side. That should give us -0.55. Don't lose that negative. I'm going to divide by my -1. So now I have this. All right, so now since I'm dealing with e, to solve this, I'm going to natural log both sides, because that allows the e to cancel, and I'll have natural log of 0.55 is equal to -0.15d, and now I can just go ahead and divide. Now, this is a situation in which you would want to give a decimal answer, right? Because if I told you that it took natural log of 0.55 divided by -0.15 days, you would have no idea what I'm talking about. So let's type that in. And we get about 3.986 days. Okay, let's try another one. Loudness of sound. The loudness, L of x, measured in decibels of a sound of intensity x measured in watts per square meter is defined by this guy right here, where I sub 0 is 10 to the -12 watts per square meter, and that's the least intense sound that the human ear can detect. Determine the loudness of heavy city traffic that has an intensity of this guy. All right, so if you look, they actually just want us to plug everything in. So we are finding not L of x anymore, but L of 10 to the negative third. Watch that notation, please. And then the formula says 10 log our x is this guy over I sub 0 they told us. Okay, so let's use some laws of exponents here. See how both of these guys are negative exponents, so they're going to flip-flop. I'm just going to do this off to the side. And then we have the same base, so they can subtract. So I'm just going to rewrite this like this. 10 to the 9th. All right, well, this is something that we should actually be able to evaluate without a calculator, because notice there's no base given here. That means that this is the common log, or log base 10. I'm just going to put a little 10 there, which means these guys cancel. And another property of logs, which we'll get into more, the 9 is going to come forward and it will multiply to the 10 that's already there. So our final answer will be 90 decibels, because 10 times 9 is 90. All right, and our final problem. Solve the following for constant k, give an exact answer. And then we'll use that value of k to evaluate y in the given equation. So, all right, let's solve for k. Well, let's divide by 4. All right, and then we have an e here, so how about we natural log both sides? So I have natural log of 5 equals 0.07k, and then to solve for k, I'm just going to divide. Now, for whatever reason, people always really want to round k. K is a constant. You should always leave it as exact. Okay, do not round k ever. So now let's use the exact value of k to evaluate y in the following equation. So we'll just go ahead and we'll plug this guy in. So one thing that I like to do with these types of problems is I like to store the k value in my calculator. So the way I'll do that is first I'll just type it in. Natural log of 5 divided by 0.07. So this is my k value. So now I'm going to press the store button right down here, and I'm just going to store this as, I don't know, whatever I want. I'm usually going to use x. So now what that does is every time I press x, I get my k value. So that makes it a lot easier to type in something like this, because now I just need to type in, move this over, 15 e to the 0.02x instead of typing in the natural log of 5 over 0.07. All right, so we should get 23.757. And there's your answer. Okay, so that was our lesson on solving logs, and please let me know if you have any questions. Have a great day. Bye.